Well, before we do a couple of tougher examples, let's summarize what we learned about expanding log expressions. And you should memorize these three rules. The product rule just says that the log of mn is equal to the log of m plus the log of n. And it works for no matter what the base is. So this is true. Without the base there, it means base 10. That's perfectly true, but the general one is b can be any positive number you want it to be. It can be any base of the log. Remember, b is just a positive number. The quotient rule tells us that the log of m over n is equal to the log of m minus the log of n. And again, we'll put the base b for all of them. You can use any base you want. Basically, if you're given this left-hand side, then you have to keep the same base on the right-hand side. And then the third one was the power rule. That says if you take log of m to the p power, it doesn't matter what the base is, you can pull the p down to the front. This p can come down and be a multiplier here instead of being an exponent there. So that's equal to p times log base b of m. Went down there a little bit. Okay, so those three expanding log expression rules you should memorize. All right, how about a couple of easy true-falses? True-false, is log base b of m plus n equal to log base b of m plus log base b of n? No, absolutely not. How could we change it to make it a true statement? We could make it the product rule. We could make that a multiplication instead of an addition. Then this would be perfect. But this is absolutely, we don't have a good expansion tool for log of m plus something else, m plus n. Number 9, is log base b of the fraction m over n equal to log base b of the numerator over the log base b of the denominator, like this? No, absolutely not. We do not have formula for either of these two. How could we fix this? Well, we could change the right-hand side to be log base b of m minus log base b of n by using the quotient rule. Okay, well, actually, I guess this was true or false, so I'm going to circle F for false in both of those. Okay, now let's do some longer expansion problems. Expand these expressions. Log base b of. And if you can't quite make that out, it's x to the 4th times the cube root of y. All right, well, the first thing I want to do is get rid of the radical and write an exponent in its place. So remember that y to the 1/3 exponent, the 1/3 power, write that again, y to the 1/3 is the same as the cube root of y. So if we write this then as log base b of x to the 4th y to the 1/3. That's a good starting point. So what will we do next? And let's make a note right now, you can't use the power rule right now. You can't bring the 1/3 down to the front, or you can't bring the 4 down to the front using the power rule. Because you could only do that if it were outside of this. This is log of all of this. So if I had an exponent of p here, I could bring the p down. But the 1/3 is not the exponent for the x to the 4th. It's only the exponent for a portion of it, the y. So the first thing we need to do is notice that we've got a multiplication here and break it up into 2 logs using the product rule. So that's equal to log base b of x to the 4th plus log base b of y to the 1/3. And now we'll use the power rule to finish it up. Now I'm going to bring this 4 down to the front, and I'm going to bring this 1/3 down to the front. So I will get 4 log base b of x plus 1/3 log base b of y. So that's the fully expanded version of this one single log. All right, let's go to the second one. Well, first thing I'm going to do is, what do you think? Well, I'm going to do two things at once just to save some space. I'm going to make a note that radical x is x to the 1/2, so I'm going to rewrite that as x to the 1/2. But I'm also going to do what? Am I going to do the product rule first or the quotient rule first? I'm going to do the quotient rule, because this is the entire top divided by the entire bottom. So I'm going to take the log of the top minus the log of the bottom. So log base 5 of w cubed x to the 1/2 minus, and if I said product rule, I meant quotient rule. We're using the quotient rule here. Log base 5 of 25 y cubed. All right, well, what's that equal to? Let's keep simplifying. This first term, now I'm going to break this up into a product rule problem. So it's this y cubed plus x to the 1/2 power. W cubed times x to the 1/2. So it's times here. Let's break this up into two of them. Log base 5 of w cubed plus log base 5 of x to the 1/2 minus, and now let's do the same thing with this. It's 25 times y cubed minus log base 5, 25, plus log base 5 y cubed. Now, did I do that one entirely correctly? I did not. This needs to be in parentheses. It's minus this entire log expression, right? So I expanded this entire log expression, so I need to maintain those parentheses. So this plus is really going to become a minus. And I think I'll do the power rule and finish up this problem. And by the way, what is this equal to? Log base 5 of 25. We know that number. The exponent, you raise 5, 2 to get a 25. That's just 2. So I'm going to replace that. So equals 3. Log base 5 of w. I brought the 3 down to the front using the power rule. Then I'm going to do the same with the 1/2 here. Plus 1/2 log base 5 of x minus this, which is minus 2, and minus, bring the 3 down using the power rule, the exponent, 3 log base 5 of y. I think that covers it all. So we expanded this log into this long expression. And before we review that, I want to show you a quick way of making sure you understand this. Log of AB over CD. You'll discover after you do a few more of these problems. Notice that we got a positive for this term, a positive for that term, and we got negatives for both of these terms. The negative and a negative. The factors that are in the denominator, when you expand them, each one of those factors needs a minus sign. So without any parentheses, I know right now that this is equal to the log A plus log B minus log C minus log D. So if you'll just remember that, it might save you a little bit of time. When you expand something like this, you've got two things multiplied upstairs, two things multiplied downstairs. The two things that are multiplied, when you expand them, they get minus signs in front. So log of A, log of B, plus log of B, minus log of C, minus log of D. Okay, so the summary for condensing log expressions is exactly the same as this, only the left-hand sides become the right-hand sides and the right-hand sides become the left-hand sides. So when we start with this expanded log expression, two logs, and they're the same base, we combine them into log base B of mn. Similarly, when it's a minus sign, to condense them into one log, we get log base B of m over n. And the last rule is a power rule. This p that's being multiplied by this log this p can become an exponent of what you're taking the log of, this m. So log base B of m to the p power. All right, so we're asked here to condense each of these three log expressions, which means write them as a single log. So we're adding here, so log of m plus log of n is log of mn. So this is equal to log of 25 times 4, which is log of 100, which is 2. So the log of 25 plus a log of 4 is equal to 2. We first condensed it into one log, and we had to multiply 25 times 4, giving 100. And log base 10 of 100, what exponent do you raise 10 to get 100? 2. And let's see what we get here. Here we've got the natural log of 7w plus 6 plus the natural log of w. Really, there's nothing we can do other than condense it using the product rule. ln of, maybe I'll write it like, we have to multiply this times this. W times 7w plus 6. And if you wanted to, you could multiply it out. You don't have to, though. 7w squared plus 6w, you'd have to put it in parentheses. But nothing we can really do. Nothing else we can do about this. But that is condensed. All right, the final one. What do we do here? I've got this thing multiplied by 2. This one's not. And we don't have a way to condense in that scenario. So what do we do to get rid of this 2? Not to get rid of it, but we can move it up to here. And then we'll have log minus log, and we can use the quotient rule. So we first do log of x minus 3 in parentheses squared minus log x. Now we have log minus log, which is equal to log of this over that. Log of x minus 3 squared over x. And that's condensed.